All right, deep dive time. Let's talk about building an automation framework from scratch.
Ooh, exciting.
Right, I know. Building a testing framework might not sound like the most thrilling topic, but UT.
It's important stuff.
It really is. Think of it this way. This is the stuff that separates those coding cowboys from the software superstars.
Yeah, a well-built framework. It's kind of like the secret weapon to getting that efficient, reliable software.
Totally. I mean, it's like having the superpower that just helps you catch all those pesky bugs before they become huge headaches.
Yeah, less time fixing bugs means more time to do too much anything else.
Exactly. And to help guide us on this deep dive, we have a document that was submitted outlining the whole process. So by the end of this, you'll be throwing around terms like page object model like it's nothing.
But more importantly, you'll understand why these concepts matter. And you'll see how they can actually help you ship software faster with fewer issues.
Right. So let's start with the basics. What exactly is an automation framework?
Well, imagine building a house, right? But you're doing it without a blueprint.
Oh, that sounds disastrous.
It would be a disaster.
Duh.
You might end up with like a door where windows should be or worse.
Yeah, I'd rather not think about it.
So an automation framework is essentially the blueprint for your testing process. It brings order to the chaos.
So it's all about structure and organization.
Absolutely. A structured approach to creating, running, and maintaining those automated tests. Because without it, you're likely to be repeating tasks, wasting time, and increasing the chances of errors.
Okay, that makes sense. Now, are there different types of frameworks? Like, is it one size fits all or?
Not at all. There are actually several types, each with its own strengths and weaknesses. You can kind of think of them like different architectural styles for houses.
Okay, I like where this is going.
So we've got linear frameworks, which are pretty straightforward and simple, like a classic ranch style house.
Classic, yeah.
And then there are modular frameworks where you create these reusable components that you can assemble in different ways, kind of like building with Legos.
Ooh, the Lego analogy. I love it. So if I need to make a change, I can just swap out a module without redoing the whole thing.
Exactly. You're getting it.
Yeah.
Now, thinking about the project you mentioned, working with a large data set, a data-driven framework might be the best option in that case.
Oh, interesting. Why is that?
Well, it lets you run the same test, but with different data.
Makes sense.
Super useful for testing how your application handles various inputs.
That sounds perfect for what you're working on.
Exactly. Now, let's not forget about keyword-driven frameworks.
Okay, what are those?
These use like plain English instructions.
Yeah.
So even team members, even if they don't have coding knowledge, can understand and contribute to the testing process.
So it's kind of like having a universal translator for your testing team.
Exactly.
Yeah.
Then you have hybrid frameworks, which, as the name suggests, combine elements from different types to suit specific needs.
Right. Kind of a mix and match situation.
Exactly. And finally, we have behavior-driven development frameworks, or BDD. These prioritize collaboration. Everyone's on the same page. Developers, business analysts, everyone.
Okay, so choosing the right framework seems like it's a pretty crucial first step.
Absolutely. Like choosing the right architectural style for your house.
Sure.
It needs to fit your needs and the environment you're building in.
Okay, so we've got our different blueprint styles, right? Now, what about those core components, those essential building blocks of any robust automation framework? What are those?
Well, every good framework, right? It needs a system for managing those test scripts.
Okay.
Think of it like organizing your kitchen.
Okay.
For maximum efficiency. You would want to be rummaging through drawers looking for the right spice in the middle of cooking some complicated dish, would you?
Definitely not. That leads to disaster.
Exactly. Chaos in the kitchen, culinary disaster. So, test script management, it's all about keeping your scripts organized, easily accessible.
So everyone knows where everything is and can find what they need.
That's the idea. Next up, we have reusable code modules.
Okay.
This is where you create functions or methods for those common actions that are repeated throughout your tests. It's kind of like having those pre-made spice blends.
Oh, right.
You know, the ones you can use in tons of different recipes.
Yeah, it's all about efficiency.
Exactly. Saves you time and ensures consistency. Then there's test data management, which is all about separating your test data from your actual code. Like you might have separate shopping lists for different rooms when you're furnishing a house.
Oh, right.
You want to manage your data separately.
Right.
So that way updates and changes are a lot smoother.
So if you decide to, redecorate one room, you don't have to rewrite the shopping list for the entire house.
Exactly. Now, just as important as having blueprints and materials, you need good documentation. Right.
Right.
That's where reporting and logging come in.
Okay.
Think of it like your detective's case file for tracking down bugs.
So you can see what happened, when it happened, and why it happened.
Exactly. Detailed reports show you which tests passed, which failed, and why. And logging gives you like a behind-the-scenes look at your tests.
Okay.
Super valuable for debugging.
Makes sense. What else is essential for a strong framework?
Well, configuration management.
All right.
Think of it like being able to switch between work and personal settings on your phone. You know,
Right.
you want to manage those environment-specific settings without hard-coding values in your scripts.
So flexibility and adaptability.
Exactly. And lastly, and this is the piece that brings it all together, integration with CI/CD tools.
Okay.
This allows your tests to run automatically whenever code changes are pushed. It's like having a self-cleaning oven.
Oh, I love a self-cleaning oven.
Right. Tools like Jenkins or GitLab, they become your automation assistants.
That's pretty cool. Okay, so we've got our key ingredients for a robust framework, but how do we actually build this thing? I mean, it sounds pretty massive.
It doesn't have to be overwhelming. Remember, Rome wasn't built in a day.
Right.
You can start small and gradually add more features. The first step is defining the requirements, which is like laying the foundation for your framework.
Right, I'm ready to break ground. What does defining requirements actually look like?
It's all about understanding the scope of the project.
Okay.
What kind of software are we testing? What are the essential tests we need to run? And what tools are best suited for the job? Just like a contractor needs to know what kind of house they're building before gathering materials.
So it's like figuring out if we're building a modern mansion or a cozy cabin.
Exactly. Once you have a clear picture of your requirements, then you can move on to selecting the right tools, which is like choosing the best materials for the job.
Okay.
We need to consider the type of testing we're doing, the programming languages we're comfortable with, and of course, the budget.
Right, so it's not just about picking the shiniest, newest tool on the market.
No, not at all.
You need to understand which tools will help you build a framework that's, both robust and easy to maintain.
Absolutely. So, for example, if you're testing a web application, Selenium's a popular and reliable choice.
Okay.
It's like the trusty hammer in a carpenter's toolbox.
Solid. Reliable.
But if you're testing mobile apps, you might need something more specialized, like Appium.
Oh, okay.
It's designed specifically for testing mobile apps, and it can handle both Android and iOS platforms.
So it's like having a Swiss Army knife of mobile testing tools.
That's a great way to put it. We'll dive into some more tool comparisons a bit later, but first, let's move on to setting up the project structure. This is where we create the blueprint, with clear modules for our code, tests, and data.
So we're talking about organization, creating that logical structure, right?
Precisely. We want to organize our project in a way that makes it easy to navigate, maintain, and add new features in the future.
Makes sense. Like having a well-organized workshop where everything has its place.
Exactly. We might have separate folders for our source code, our tests, our test data, and within those, we might have subfolders for different components of the application we're testing, like login functionality or user registration. Simple example, in a bash environment.
Whoa, hold on. You're throwing code at me already. I thought we were still in the blueprint phase.
Don't worry, it's just a visual aid.
Yeah.
No need to memorize this right now. Just imagine creating folders like src, main, then Java within that, and subfolders like pages for our page object files, utils for utility functions, and so on.
Okay, I see. So we're just setting up the framework, like where everything is going to live.
That's it.
Okay, that makes a lot more sense. It's like drawing up the floor plan before you start putting up the walls and furniture.
Exactly. And once we have our project structure in place, we can move on to one of the most important steps in building a framework, implementing the page object model, or POM.
Okay, the page object model. I was kind of excited to learn about this one. What is the deal with the POM?
Well, think of the POM as a set of detailed instructions for each room in your house.
Right.
It helps us separate the test logic from the actual elements on the page.
Got it.
So instead of having code scattered throughout your tests that directly interacts with buttons, forms, and other elements, we create these page objects that represent each page of our application.
So each page object is like a blueprint for a specific page.
Exactly. Each one contains the locators for the elements on that page and the methods for interacting with them. This makes your tests much easier to read, understand, and maintain.
And why is that?
Well, think about it. If the UI changes, you only need to update the page object. not every single test that uses it.
Yeah, that's super handy. So it's like having a master control panel for each room in the house, and instead of rewiring the entire house as something changes, you just adjust the control panel for that one specific room.
You got it. So for instance, let's say you have a login page. You could create a login page object that contains the locators for the username field, the password field, and the login button.
So it's like giving a map to our automated tests so they know exactly where to find everything.
Precisely. That way, if the developers decide to, move the login button or change its ID, you just update the login page object, and all your tests will still work perfectly.
That's incredibly efficient. What happens after we've set up our page objects?
Well, remember how we talked about separating our test data from the code?
Yes.
Well, now it's time to put that into practice.
Okay.
We need to add test data handling. Think of it like those separate shopping lists for each room's decor.
Right, so you can easily swap out the couch or the curtains in one room without having to redo the entire house.
Exactly. We might store our data in external files, like Excel spreadsheets, and we use libraries to read the data from those files.
Okay.
This makes our tests more data-driven, which allows us to run the same test with different inputs and scenarios.
So we can see how our application performs under different conditions.
You got it. This is crucial for ensuring that your software can handle, a wide range of user inputs. Those real-world scenarios. And speaking of real-world scenarios, let's not forget about those detective case files we discussed earlier.
Right.
Time to set up reporting and logging.
So we're talking about having a record of what happened during the test.
Exactly. We want to see what passed, what failed, and any information that could help us with debugging.
Okay.
Think of it like having progress photos and a detailed logbook for your house build. Tools like Extent Reports can generate beautiful, visually appealing reports that summarize your test results.
Oh, nice.
Yeah, so it's not just about lines of code and data, but about having a clear, understandable record of how your tests are performing.
Right. And especially for, communicating with your team and stakeholders, especially those who maybe aren't as familiar with the technical details.
Exactly. Are you ready for the exciting part?
I think so. What's the exciting part?
Time to automate everything. Let the robots take over.
All right. Bring on the robots. What do we do?
It's time for integration with CI/CD.
Okay.
Remember the self-cleaning oven we talked about?
Yes.
We're going to set up our framework to run automatically whenever code changes are made. Tools like Jenkins, GitLab, or Azure DevOps can help us achieve this continuous integration and delivery magic.
So it's like having a robot crew that automatically starts building additions or renovations whenever new blueprints are added.
That's the idea. It frees up your time so you can focus on more creative and challenging tasks while the robots take care of all that repetitive, time-consuming stuff.
Okay, I'm liking this more and more.
The best part is, by automating your testing process, you catch bugs early and prevent them from making it into production. And you can deliver new features faster, more reliably.
That is amazing. Are we done?
Well, not quite.
Oh, okay.
Even with all this automation, we still have a little bit more to do. Just like a well-built house, our automation framework, it needs regular review, Review and refactor.
Oh.
This is where we step back, assess what's working well and what could be improved. Think of it like doing regular home inspections.
Oh, right. Like those routine maintenance tasks, just to prevent small issues from turning into big headaches.
You got it. It's about reviewing your code, updating libraries, fixing bugs, and refactoring as needed.
Okay, so we've basically laid the groundwork for building a solid automation framework. We've explored the different types, those essential components, and even the initial setup steps. What are some best practices that we should follow? Those pro tips that'll take our framework to the next level.
That's a great question. There are definitely some key principles that can help you build a robust, maintainable, and scalable framework.
Awesome. I'm ready. Hit me with those best practices. Let's level up.
All right, let's do it. One of those golden rules when you're building a robust automation framework, you got to keep it modular. Think of it like building your house with distinct rooms that can, function independently, like having a guest suite that has its own bathroom.
Makes sense. So your guests aren't like wandering through your whole house.
Exactly. So in our framework, this means we're breaking down our code into smaller, self-contained units.
Yeah.
That can be reused and maintained easily. So, we might have a module for handling login functionality, another one for user registration, and so on.
So it's kind of like building a house with those prefabricated components.
Exactly.
You can easily swap out or upgrade a module without having to redo the entire structure.
Yeah, you got it. And modularity goes hand in hand with prioritizing reusability. Just like a savvy builder stocks up on like standard size lumber and fixtures that can be used throughout the house, we want to create code components that can be easily plugged into different tests and scenarios.
Got it. So instead of reinventing the wheel every time, we build up this library of reusable code elements.
Precisely. It not only saves time and effort, but also ensures that consistency across your tests. And as your project grows, you want to make sure that your framework can handle the increasing complexity. So that's where Optimize for Scalability comes in.
So it's like designing the foundation of your house to support future expansions, right? You don't want to be limited if you decide to add a second story or a backyard deck later on.
Exactly. We need to think ahead and design our framework in a way that allows us to easily add new tests, data sets, even integrate new tools and technologies as our needs evolve.
Okay, that makes sense. But let's be realistic, sometimes code can get messy, especially when, multiple people are working on it. So how do we make sure that our framework is easy to understand, easy to maintain, especially over time?
That's a crucial point. That's why I emphasize readability right from the beginning. Imagine if the blueprints for your house were like scribbled on napkins, full of these cryptic symbols. No one would be able to understand them.
It'd be a nightmare for the construction crew.
Exactly. So we're talking about writing clean, well-commented code that even someone new to the project can understand.
So we're talking about using meaningful names for our variables and functions, consistent formatting, adding comments that actually explain what the code is doing and why.
You got it. It's like writing a clear instruction manual for your framework.
So we've got modularity, reusability, scalability, readability. What else? Are we missing anything?
Well, just like any well-built house, your automation framework, it needs regular maintenance.
Mm-hmm.
It's like doing those annual checkups, those routine maintenance tasks, just to prevent, small issues from becoming major headaches down the road.
Exactly. Preventative maintenance, always a good idea.
You got it. It's about reviewing your code, updating libraries, fixing bugs, and refactoring as needed.
Okay. Anything else?
Oh, and let's not forget about automate error handling. Think of this as installing safety features in your house to prevent accidents.
Oh, okay.
You want to make sure your framework is as robust and resilient as possible.
So, like, smoke detectors, fire extinguishers, circuit breakers, things that prevent those small mishaps from becoming major disasters.
Exactly. So in our framework, this means implementing mechanisms to gracefully handle any unexpected errors or exceptions. You don't want your entire test suite crashing just because one test encountered a minor issue. It's about building in safeguards, so your framework's more reliable and resilient.
Okay, these best practices are starting to feel like common sense, but it's amazing how often they're overlooked, like forgetting to check the batteries in your smoke detector.
That's a great analogy. And just like with home safety, it's always better to be proactive, take those steps to prevent problems before they arise. Now, shifting gears a bit, let's talk about the tools and technologies that can really bring our framework to life.
Okay, let's dive into the toolbox. What are those top contenders, the go-to brands for each stage of framework building?
All right, so first up, you've got your programming languages, the foundation of our code. Java, Python, and JavaScript, those are popular choices, each with their own strengths and weaknesses. It's like, choosing the language for your blueprint.
So like English, Spanish, or French?
Exactly. The language you choose will depend on your team's expertise, the specific requirements of your project, and the libraries and tools you plan to use.
Okay, so we choose our language. What about the actual power tools for creating and running our tests? What are those?
For web testing, Selenium's a solid choice. Been around for a while, it's reliable. Works with a wide range of browsers. It's like that trusty hammer in our toolkit.
Reliable and versatile. I like it. What about for mobile apps? Those are a pretty big deal these days.
Absolutely. For mobile testing, we've got Appium, specifically designed to handle both Android and iOS apps, making it a super versatile choice. Think of it as the Swiss Army knife of our automation toolkit.
Okay, so we've got web and mobile covered. What about APIs? Those are becoming more and more important in modern software development.
You're right. For API testing, we have tools like Rest Assured or Postman. They allow us to send those requests to APIs, check the responses, and make sure everything is working as expected. It's like having a specialized set of tools for like your plumbing or electrical work, making sure everything's connected and flowing smoothly behind the scenes.
Love that analogy. So we've written our tests, but they're probably scattered all over the place. How do we keep them organized?
That's where test management frameworks come in. Think of these as the project management software for our tests. So you have TestNG, JUnit, and Cucumber. They're all popular choices, each with its own approach to organizing, running, and reporting on tests.
So they basically provide a framework for managing our tests, keeping them organized, making sure they run in the right order.
Exactly. They bring order to the chaos and help us track our progress. And speaking of tracking progress, don't forget about those fancy reports.
Right. We need those visually appealing reports to, show off all our hard work, impress the stakeholders. What tools can we use for that?
Allure and Extent reports are excellent choices. They give you that detailed information about test execution, including, pass-fail status, execution time, any errors or exceptions encountered. It's like the 3D modeling tools of the testing world. They help you visualize your test result in a way that's both informative and engaging.
So we've got tools for writing tests, running tests, managing tests, and reporting on tests. Is there anything else? What else do we need to complete our automation toolkit?
Don't forget the robots.
Oh, right.
We need tools for CI/CD, our continuous integration and continuous delivery. This is where those tools like Jenkins, GitLab, and Azure DevOps come in. They help us set up these automated pipelines that build, test, and deploy our code. Anytime changes are pushed to the repository, they're like our tireless robot construction crew, working 24/7 to ensure our code is always tested and ready to go.
That's pretty incredible. We've gone from this simple idea of an automation framework to like a full-blown construction project. We've got our specialized tools and our automated workflows. I'm starting to see the power of automation here.
It's quite a journey, isn't it?
It is.
And we've only just scratched the surface. There's a whole world of advanced concepts and techniques out there.
I'm feeling a little overwhelmed, to be honest.
Oh, yeah.
Before we go any further, let's talk about potential challenges. What are some common pitfalls we should be aware of when we start our framework building adventure? What are some challenges that we might encounter, and how can we overcome them?
You're right. Building a framework isn't always easy. There are definitely some hurdles along the way.
Yeah.
But, with the right mindset and approach, you can navigate those obstacles and build a solid foundation for your testing efforts.
Okay, I'm ready to face those challenges head on. Let's talk about some of those potential roadblocks and how we can overcome them. Okay, let's talk about those framework building challenges. Where do we even begin?
Well, one common hurdle is the sheer effort required up front. It can feel pretty daunting to set up all the components, choose the right tools, write all that initial code. It's like staring at this giant pile of lumber and wondering where to even begin building a house.
Yeah, I can definitely relate to that feeling of being overwhelmed, especially when starting from scratch. Any advice on how to tackle that?
Well, remember, you don't have to build the entire framework in one go.
Okay.
You can start small. Focus on one key feature or module at a time, and then gradually build up your framework over time. It's like building a house one room at a time.
Okay, so break it down into manageable chunks. That makes it seem a little less daunting. But what about those infamous flaky tests? I've heard those can be a real nightmare.
Yes, flaky tests. Those unpredictable creatures that, they pass 1 minute, fail the next, often without any clear explanation. They're like those annoying creaky floorboards that make you question the structural integrity of the entire building.
And just like with creaky floorboards, it's often hard to pinpoint the exact cause.
Exactly. Flaky tests can be caused by all sorts of things. Unstable network conditions, timing issues, or even just subtle changes in the application that you're testing. But just like a skilled carpenter can diagnose and fix those creaky floorboards, we can take steps to identify and eliminate flaky tests.
Okay, so how do we deal with these testing gremlins?
Well, first, you got to make sure your framework's foundation is solid. This means using reliable tools and libraries, writing clean, well-structured code, and following those best practices for test design.
Right, so it's all about starting with a strong and stable foundation.
Exactly. Now, what about timing issues? Sometimes those web elements can take a while to load, and tests might fail if they try to interact with them before they're ready.
Right. So how do we avoid that?
Well, that's where explicit waits come in. Instead of blindly waiting for a fixed amount of time, we can actually tell our tests to wait for specific conditions to be met before they proceed.
Okay.
For example, we can wait for an element to be visible or clickable before trying to interact with it.
So like waiting for a delivery notification instead of just constantly checking your front porch.
Exactly. Now, as your framework grows, and you start integrating with more tools and systems, you might run into some integration complexities.
Okay.
Think of it like having multiple contractors working on your house.
Yeah.
They all need to coordinate their efforts effectively.
Right. You don't want the plumber and the electrician working at cross purposes.
Exactly. So in the framework world, this means making sure that your tools and systems can actually communicate with each other. You need to choose tools that are compatible, use standardized protocols, and configure your integrations carefully.
So it's like making sure all the contractors have access to the same blueprints and they're all speaking the same language.
Precisely. Open communication and clear standards. Key to avoiding those integration headaches.
Okay, so we've covered that high initial effort, flaky tests, and integration complexities. Any other challenges we should watch out for?
Well, just remember that building a framework is an ongoing learning process.
Right.
There will be bumps along the road, but the important thing is to learn from your mistakes and continuously improve your skills.
So it's not about achieving perfection right away.
No.
But about embracing the journey and constantly trying to learn and grow.
Exactly. And as you gain more experience, you'll start to develop your own best practices, and techniques tailored to your specific needs.
That's reassuring to hear. So, to wrap things up, building a robust automation framework is really about having that clear vision, choosing the right tools, following those best practices, and of course, being prepared to face some challenges along the way.
Absolutely. And never underestimate the importance of continuous learning and improvement.
Great advice. Well, I think our listener is now fully equipped to embark on their own framework building journey. They've got the knowledge, they've got the tools, and hopefully they've got the inspiration to create something amazing.
And remember, like any well-built house, a good framework needs ongoing care and attention. Don't be afraid to experiment, explore new technologies, and continuously refine your skills.
Excellent advice. And who knows, maybe in a future Depth Dive, we'll explore some of those more advanced concepts, like design patterns or performance optimization.
I'm looking forward to it. Until then, happy building.
Happy building, everyone, and thanks for joining us on the Deep Dive.